All right, let's get started with Lesson 2, Physical and Chemical Changes. Now that we have defined what matter is and have looked at classifying matter, we can now look at the changes that matter undergoes. There are essentially two types of changes that matter can occur. They can either be physical or chemical changes, and we're going to look at the difference between both of them in this lecture video. So first of all, I want you to think about a piece of pizza here. When you take a piece of pizza, which is a mixture, a heterogeneous mixture, which we learned in our first lecture video, or first lesson, this piece of pizza, which is a heterogeneous mixture, is made up of a lot of different pure substances. When you begin to consume the piece of pizza, you begin to break it down or change it by chewing it, manipulating it in your mouth. And those changes that occur are known as physical changes. We haven't really changed the nature of the pizza. It's still pizza in your mouth, but it is now starting to get smaller or smaller pieces of chunk and make it easier to swallow. So those are known as physical changes. By the time the pizza is in your stomach and in your small intestine, chemicals that the body produces is going to interact with the pizza and begin to change it into new substances. And at this point, when we're actually changing the pizza into something new that did not exist before, those are considered chemical changes. So the process of eating contains both physical and chemical changes. Now, in order to understand the changes that matter occurs, we need to know something about the properties of the substance that we're looking with. So maybe we're looking at an element or looking at a compound or some type of mixture. We need to identify the properties of that element or compound or mixture in order to understand the changes that it can occur or undergo. So, for instance, let's look at physical properties, okay? You can think of a property as something that belongs to something, okay? So, for instance, you have certain things that belong to you, and we consider that your property, all right? You have a cell phone, and that's considered your property. Well, compounds, elements, and mixtures also have things that belong to them. And usually these physical properties that we look at are like color, odor, taste, hardness, density, melting point, boiling point, and electrical conductivity. These are just some big examples of physical properties. Different substances are going to have different color. You know that. They're going to taste different. They're going to smell differently. They're going to have different hardness, different densities. They're going to boil at different points. They're going to melt at different points. Some things conduct electricity, some things don't, okay? So those are examples of physical properties. What about chemical properties? Well, chemical properties are usually properties that we associate that when they interact with something, they describe that it's going to change into something new, all right? So describe the way a substance changes or react with when it interacts with another substance to produce new substances. For example, when iron interacts with air, especially the moisture in air, rust is going to begin to form. And so it's just natural. This is a chemical property of iron. Iron, in the presence of moist air, is going to form rust. It's going to rust. Other examples of chemical properties would be considered flammability, again rusting, tarnishing. Tarnishing is close to rusting. Another word for tarnishing is oxidation, corrosive, and explosive. All right, so those are some examples that you can put in your study guide for chemical properties. All right, let's take a moment and see if we can classify these particular properties as chemical and physical, okay? We'll put a C for chemical and a P for physical. So for instance, a substance is blue color. And that would be what? Obviously a physical change. Physical change, density, physical, flammable, it burns, so it's going to be chemical, it's going to change the substance. Solubility, dissolves, that's just going to be a physical because it doesn't actually change the substance identity. Reacts with, whenever you see the word reacts with, you know it's going to be a chemical because it's going to change the substance into something new. Supports combustion, that would be like burning, so that's chemical. Taste sour, taste is physical. Melting, physical. Reacts with water, again the word reacts with is the indication that it's chemical. Hardness has got to be physical. Boiling point, physical. Luster, okay, how shiny it is, that's got to be physical. Odor, how it smells, is physical. And finally, again, reacts with, it's going to be chemical. All right, so those are some ideas or to classify chemical and physical properties. So now let's get into the actual changes. The chemical and physical changes. We're going to start with physical change. I want you to think of a physical change is that the appearance changes, but the substance really does not. All right. In other words, we have the element over here. This is gallium. Okay. Gallium symbolized as Ga. Okay. Now, gallium has a pretty cool property. First of all, it's a metal, but it can actually melt in your hands. So if you ever put gallium in your hand, it will melt. But the process of gallium melting from a solid to a liquid is not going to change the fact that it's gallium. Even though it's melted, it is still gallium. And so a physical change really does not change the identity of that substance. All right? Even though it undergoes some kind of change, it is still the same thing. All right? Think of water melting. And if you take water that's in an ice cube and you melt it, it's still considered water. All right? We haven't changed the fact. All right? Usually when we undergo a change of state, in other words, if you do melting or boiling or freezing, those are all physical changes. You have not changed the identity. So here are some evidence that I want you to know and know these super well. Melting, boiling, freezing, evaporating, cutting something, and dissolving something, those are great strong evidence that we're just undergoing a physical change and not a chemical change. All right, so here's some examples. We got ice that's undergoing melting. Again, that's physical. Bread, it's just being cut. When you cut a loaf of bread into slices, you're not changing the fact that it's bread at all. It's still bread. It's just in smaller pieces, but it's still bread. This aluminum can, when you crush it, it's still an aluminum can, all right? Regardless the fact that it's crushed or not. We haven't changed the fact of what it is. When we dissolve something like sugar and water, that's a physical change. And of course, boiling water, all we're doing is changing its state. We're going from a liquid state to the gas state, but it still remains the same substance. All right. Chemical changes, on the other hand, is when we create something brand new. We start out with something, some kind of compound or element, and in the process of its change, it actually forms a brand new substance. This is known as a chemical reaction that's occurred, okay? And two or more substances chemically react with another, all right? It is also known as simply a chemical change. What are the evidence for a chemical change? These are some of the ones I want you to know, so learn them and study them really well. I want you to know them from the quiz. If something produces bubbles, often indicates a chemical change. Now, of course, bubbling could result in a gas forming during a phase change. All right, so you got to be careful of that. But if you see bubbles forming, it really is an indication that a gas is being made or produced. If something turns cloudy, a big change in temperature, color change, change in smell or taste, light is being produced, something blows up. Those are all examples of chemical changes and evidence that suggests that a chemical change has occurred. So be kind of familiar with that idea. All right. All right, so here are some examples, other examples of chemical changes. One of the things to really note is burning. Anytime we burn something or something is being combusted, okay, burning and combustion is really the same thing. It's going to be a chemical change. Cooking is a chemical change. We see a color change being formed, chemical change. Rusting, as we mentioned earlier, is all evidences of chemical changes. All right, so let's take a moment here and let's see if you can go ahead and classify these changes as either physical or chemical. If it's a physical, put a P. If it's a chemical change, put a C, okay? So just stop this for a minute and see what you can come up with, and then we'll check your answers. All right. Table salt. Sodium chloride dissolves in water. The key word is dissolve. That indicates a physical change. Silver is tarnishing. The key word is tarnish. That's got to be chemical. It's changing. An apple is cut. If you cut something, it's just a physical change. Heating water to steam. That's a physical change. It's just a phase change. Baking soda reacts. The key word there is reacts with, so that indicates there's going to be a change that's going to be chemical. Iron rusts. We know that that's got to be chemical. Evaporation is going to be physical. Melting is physical. Sour. All right, what do you think? Sour. Souring something is actually going to be a chemical change. When you're dissolving is physical. Rotting is totally a chemical, breaking it into making new substances. Cooking again is chemical.
Hi.
Growing grass. This is a challenging one. It can look at as both physical or chemical. The act of the grass growing, the processes, is definitely chemical, but the actual look of it is a physical because it's just getting longer, or the blade is getting longer, and so it doesn't appear that it's changing at all. So in other words, it's bigger, but it's still grass. Grass is grass, okay? So in the fact that the look of it, it's physical, and the process to make it bigger, though, is chemical. Inflate a tire, that's going to be physical. Digestion of food is going to be chemical for the most part, unless you're chewing it. That's a physical process, as we mentioned earlier. And then paper towel absorption of water, that's just going to be physical. All right, so here are some ideas about chemical and physical changes, and really that's all I have for this particular lecture video. Make sure you study your notes super well and prepare for the quiz over it.